There we go. When we're using Zoom, and probably a lot of you have used Zoom because it's been around for a while, but down in the bottom hand corner, if you haven't done this before, there's a little chat box. So we want you to push on that chat box and type in any questions that you have either during the presentation or even after the presentation, or if you feel so inclined, you could actually unmute yourself and open your camera up and just talk in front of the whole group as well. But any subject matter questions, feel free to just put that in the chat box. Or if you're having any technical questions, like you can't hear, you can't see slides or something like that, put that in there as well. Or if your chat box isn't working and you know your email, my email is listed there on the screen for you, which is swict@ksu.edu. Or if you know Keith's email address, his is kvan, that's KVAN @ksu.edu as well. And I will put this in the chat box as well. And so you'll have all that for you as well. Any other questions before we move on? Okay, we're going to go on and we'll introduce our speaker. And I'm going to turn that over to Keith, and he'll introduce our speaker for tonight.
Okay, AJ Sharda is with K-State Bio and Ag Engineering, and you can see some of the things he's been working on, precision ag and machinery, systems engineer, etc. My understanding is he came from Auburn school, and then he spent a little time at Washington State, and so he's got a lot of stuff that he's been passing out, and that's about it, AJ. Anything else you want to let him know about?
Okay, so
I think
here. Yeah.
No, I think everything looks good. What I would like to quickly say is that we have been like Keith was mentioning, my PhD work was on liquid application systems. So I came to US in 2006. So it's been good time that I've been continuing to doing work in the liquid application world. And we have been very fortunate to work very closely with all the major manufacturers. We've worked a lot with Raven technologies, for all their different systems which have come along over the last 10 or 15 or 12 years. Over the last few years, we have a really strong partnership or support system from Case New Holland. I really want to acknowledge their support. We have a lot of equipment from them, and a lot of different projects just to understand how these systems behave and what do we need to do to make them better. So.
Alrighty. AJ, do you want me to share my screen first and ask the first poll question real quick?
Absolutely. Go for it.
Okay. All right. So let's do that. Okay. This is going to be what's called Poll Everywhere. So if you guys have not used Poll Everywhere, grab your cell phone here. You can go right into pollev.com/Sandra Wick 135. So I'm going to give you some time to do that. Okay. Then once you get into that system, you will have to set up your account. And then you're going to text, the address that you're going to text to is 37607. And you're going to text in the comments, Sandra Wick 135. Then you can answer these questions. Has everybody found them yet? Because you should be. And then once you get in there, you can answer these questions. Which technology are you currently using? So it's either A or B, the flow-based system or the PWM constant pressure. So I'm going to get in there and see if I can get this to work here. Join that. Just type your name in. Continue. And then you either answer one of those questions. So has anybody found them yet? Keith, are you in there? I'm in there, and I'm going to answer the first one. Oops, I didn't mean to go to the next one. Let's get rid of this. Whoops. I don't see any things coming in. How are you guys doing? If you just want to tell me, is it working or what? Aha! Somebody answered it.
I don't know.
Activate. There. Now can you guys answer it? I had to activate it. Sorry. Are you guys seeing the screen?
Yeah.
Okay, great. I don't know if it's telling me how many responses, but I think there's about 7 or 8 people on. So, but that's how it works. So it looks like all of you have answered flow-based system. Is that correct? So I guess with that, we'll go on or clear this responses and I'll unshare. And then if you want to share yours, AJ.
Yes, I will.
Okay.
All right. Can everybody see that?
Yeah, now you just need to get it in a presentation mode. There you go.
Cool. Awesome. Perfect. So welcome everyone. We have a smaller group. If you guys have any specific questions or you want me to focus on only one or either one, so what the way I have my presentation is, I'm going to talk something very, very brief about just what are the basic needs, what's going on, what are the typical concerns. Then we're going to talk about what our goal is in terms of implementing the application in a right manner, all right? And after that, I'm going to talk something about what we have learned over the years in terms of flow-based system, how to make sure that how we can use that technology to the best of our ability. And then I'm going to switch some gears and talk more about what is happening in the pulse width modulation world, because not one, not two, every manufacturer has a PWM or a pulse width modulation system. And more and more sprayers which are coming out of the factory these days, they have an option of PWM. And my general perception based on talking to people and all that is there's a widespread acceptance for these systems in terms of implementing as new technology on farm. So if you have anything specific you want to talk about, just drop a message in the chat. Either Sandra or Keith can take a look at that, and we can quickly switch gears and talk more specific on those lines. But to just kickstart few things, what I quickly want to lay out to you guys is some of the things which have been, you can call concerns, you can call constant questions, you can call as discussion points every time we sit down on a bar after a big meeting, or outside in a conference hall. And some of these things are very common. You guys have seen it, you know it all along. Number one thing on everybody's mind is still drift, right? How can we manage drift so that we keep the product within our field boundaries? We keep the product by doing that, don't harm anybody else's crop, don't lose our product in terms of all the dollars and cents we are spending on that, but also timely control of everything. So how do we do that? That's every time we have something, okay, we keep talking about it. We still talk about herbicide resistance and weeds. I think we can pick up any journal, whether it is Crop Life, Precision Ag, and whatever. So I can tell you, the last 10 years, I've been reading all that, and every issue or other I pick it up, there is something about herbicide resistance. What's happening? There are new weeds, new chemical compositions, and all that stuff. We still talk about right place, right time application rates, because we're going to be talking something about in our presentation here, that are we able to apply the product in a manner we intend to, or are we going back and forth in time? The rate I want to put 10 meter, behind me is what I got now. And some of those things are still there. Product label, I talk to people in FMC and other people, there are new chemistries, things about, more residual nature of those things. So we have to be very conscious about what these product labels are. What do they say or suggest in terms of how to apply the chemicals, rate, speed, and wind speed, and all that stuff. We have to be very conscious about that. Then we also talk about things like crop damage, like how quickly, timeliness in crop, how quickly I can get in and out. If you guys might have heard or not heard, Raven came out with a new technology, which is row sense. So it can see the row, of the crop. It will manage the movement of the tires in terms of that there is minimal damage, and absolutely there's no damage, from that standpoint. So companies are starting to recognize that larger machines going through the field multiple times have to be timely. They have to put some more intelligence in terms of making sure that we don't damage the crop in any way or manner. Now, in terms of what we have, 10 years ago, rate control systems used to be pretty bare bone. Now we have very advanced liquid application systems. We have a lot of drift reduction technologies, or we can say options in our hand where we can do something about it. I really want to, showcase this picture at the bottom. This is one of the experiments I was engaged in one of my PhD programs. Projects. I'm sitting here with the operator, collecting a lot of data, making sure that some of our nozzles on the left side, looking at the screen, they shut off because it's a buffer strip. I don't want to damage all that, and it worked, right? So that was one of the things from that standpoint. I don't want to emphasize anything from a goal perspective. We want everything going, everything right overlap, all those things. We don't want any nozzles to be off. I want to apply the product in terms of the rate I want to apply, throughout the field. So before we go to this slide, Sandra, can you please put up our next question for everybody?
Yep, I will do that. So I'm going to have to stop your screen real quick.
Please, yep.
Okay. And then I will put this up. And hopefully we can get the second one to work.
It'll work. It'll work.
All righty, let's go up to the second slide and start that. Okay, so the same way, which technology, oops, sorry, next slide.
Yep.
There you go. So this is a multiple
No,
choice.
so we need to go to the
Oops,
third.
oops, oops, next one.
Yep.
This one.
Yep.
Sorry.
No, you're fine.
Okay.
It's an
So what are the most
dinner,
critical?
It's
Okay.
an after dinner casual discussion. So, everybody can jump in.
So what are the most critical? Let's see, I may have to activate this. Activate. There you go. Now you should do it. What are the most critical considerations when you are conducting an application or putting on an application? Pressure uniformity, droplet spectra, boom height, drift, or all of the above? So let's see what answers come in. Nobody's voting yet. Is it not working? Because I don't see any responses yet. Are you guys getting in? Can you guys hear me?
I am not getting in.
You are not getting in.
But
Oh, shoot.
that could be me.
Okay, if you guys just want to put your answers in the chat, how about if we do that?
Okay, that's good.
So you're either going to use A, B, C, or D. You could use A, B, C, or D, or you could write it out. So A would be pressure uniformity, B would be droplet spectra, C would be boom height, D would be drift, or E would be all the above, or just type in the answer. So I'm going to stop sharing this since it won't work for some reason. Because it looked like some of them submitted, but it's not going through. So I have some that are answering in the chat. One person said all the above. Keith said all the above. How about the others on? Any ideas? Okay. I think most of your answers said all the above, AJ.
That's absolutely fantastic. That's what we want from, before we jump into the next slide. So I'm gonna get started here. Okay. Am I back where I just
Yes.
left? Okay, cool. So just like you guys said, all of these things are very, very critical. Now, we want to really quick dissect a few things, how to get that, right? We talk about it, that, but how to go around that part, right? The number one thing, in terms of application needs, right? When we are going for application needs, the number one thing everybody wants is that I want to maintain my target rate, right? That's exactly what you want. You started from label, that's what your application rate should be. Even if you're doing constant rate or variable rate, I don't care, but you want that rate to be constant. Now, when you want that rate to be constant, since everybody said that they are using flow-based systems, I want to make sure that I have a correct flow rate within my plumbing system for that travel speed, all right? And that has also to match with the number of sections on or off. That means that how many nozzles or how many booms are on or off. Looking at all those two things, my system should put out just the right amount of flow rate into the plumbing system to give me that right target, right? That's the first thing. Now, second thing is you don't want to care whether it was a straight run or a curvilinear pass or a contour or what we can call turn. I want that my application rate should be constant from nozzle 1 to nozzle 73 or 85, whatever, however many nozzles you have. Each nozzle should do it. So that's one more thing I want to start interjecting. We're gonna talk about 2 or 3 things which I really want you guys to take back home. This is the first thing that I want to start asking, that is every nozzle doing the right thing or not, or is just something happening on my boom. So my goal is nozzle by nozzle is what my requirement, because product is costly, equipment is costly, technology is costly. My expectations are high, right? I want that to happen for each nozzle. The next second thing to happen, to get my money back and all that, is I want coverage, because that's going to give me the control aspect of it, right? Now, to do the coverage aspect of it, the major thing in that is your droplet spectra. The one thing you just said, right? I want my droplet spectra to be right, right? And that, again, irrespective of speed. I don't care, if you just, well, you care, but the droplet spectra should not change dramatically, going up and down the field. All right. Now think about it. Droplet spectra is directly related to your application pressure, since we all are using fixed orifice nozzles, and also depends on the overlap and all that part of it. And then to some extent to the boom height as well. Now, my question to you guys is, since you guys said you are using flow-based system, when we go up when we speed up and when we slow down and I speed up, I have to put more volume in the plumbing system, and I have to put more product out, and my pressure goes up. And same way, when I slow down, my pressure goes down. Now that's one scenario in which, if there are ways of doing it, but I may be in a situation where I may not be able to maintain my droplet spectra. All right, that's one thing which can happen. The other thing which is very important is the boom height, which is also part of the coverage, right? Because if your booms go high, and I really want to show you guys my arm, right? When we spray, my boom goes like this, right? Most of the time, just this is my pivot point. And when my boom goes up like that, now I'm not spraying straight down, I'm spraying at an angle, and sometime into the wind stream as well. So all of these things are very critical. I want to make sure. So what to do to get good coverage? I should be conscious about that I maintain my pressure in a range based on my nozzle selection, so I get my droplet spectra consistent. All right, you can select a good nozzle for that, and you can maintain some speed to get that done. And we'll talk more about that. And the third thing is drift. So if you guys can, drift is all about nozzle selection, boom height, and definitely in terms of what the environmental conditions are. All right. So I really want you guys to take home some of these things, that you want rate to be constant. Rate means nozzle by nozzle. If you are, whatever I'm doing, I want to make sure based on my speed and whatever it is on or off, I want the right product volume coming out of each orifice. That's what my goal is. Coverage, all related to pressure, has to be consistent all around the field. It has some bearing on the variation of pressure which happens, and the drift aspect, which is one of the most important things. You guys are going to see more and more work going around that, with booms going larger. How do I manage my booms? Because it has huge impact both on my coverage and on my drift. All right. So moving forward, very quickly, you guys have seen it. Flow regulation. What I have is I input my target rate. I have my ground speed going in, and my system catches in terms of what is my spray width, how many booms and how many nozzles are spraying. And what it does is it looks at the flow meter, right? It does all the calculation based on speed and spray width and my target rate. It says I need X gallons per minute into my plumbing system. And if this guy, flow meter, says, hey, I'm up or down, then this field computer or ECU kind of a thing, it sends the command to my flow regulation, which is your PWM, proportional PWM valve sitting on the, on the pump, right? That's very simple. That's all what we do. Now, I just want to put it up because, we are laying a groundwork for some of the discussion which is going to come along. Now, for the next few slides, we're going to look at what the flow compensation, the variable rate technology look like, what is current flow-based systems are doing in terms of operator feedback, automatic section control, data logging, and in terms of some case studies, and then we go through some of the PWM aspect of it. All right. Now, very quickly, in terms of application control, we have all the new sprayers which are coming with weight control systems, guidance. So there is no way there is any technology which is coming out like that. Now, I want to show you this slide really quick. Focus on that picture. This is, one of the things which we used to use. It is, rate controller for flow-based system. I have a bunch of things going on. This is one of the sprayer we used to drive or, operate. And most of the times when an operator looks at the screen or wants information in terms of what is going on, I look at this monitor and ask for information, what's going on. And if you guys all are with me right now, the only piece of information which is available right now from these systems is, am I on target or not? All right. If I was supposed to do 15 gallons, am I doing 15 gallons or not? Or it will say you are at 15 or 14.5 or 13.5 or 15.5, something like that. All right. So that's the only information which is available from these systems as of now. Now, and some of these newer systems which show you the coverage map in terms of how you are spraying and all that starts to add some more component to it. But this is my source of information, for most of the time. Now, we won't touch, more much on this thing, but I really want to emphasize how much automatic section control has come along. Is such a benefit in terms of automatically shutting off the control sections on areas which you have already sprayed or does not need any application, whether it is buffer strip, grass waterways, and all that, so that you can minimize double application or waste of that product. All right. Now, in terms of benefit, we used to have some automatic, we used to have manual switches to go along, but going to automatic system, you can see in this plot that we have huge savings in terms of skips, which is shown in red. So I literally have no skips, and I have a lot of savings or reduction and overlap, which is shown in the blue regions as well. Now, application data logging, all of these systems, they are giving a lot of data. All right. But I know, and you guys know, that how much work and how much data we are handling on a day-to-day basis. But don't forget it, you have this data on your back pocket, which can show what rates you really applied. Right? You can look at those things. You can look at what were your speeds, because what you can do by doing that is you can start to manage how your operators are driving. Are they driving too fast, too slow? What are the speed ranges and all that? And you can show this data to them to kind of educate how to implement this technology to the best possible manner. All right. Now, getting on to some of the discussion I really want to do with you guys is I'm going to show you two fields. One field is a rectangular field, and another field which is a more irregularly shaped field, and has a couple of electricity poles. There are there is a sinkhole here, a couple of grass waterways, and all that stuff. All right. Now, what you are seeing here is the extent of off rate, means how much off I was from my target rate. Many people say different things based on talking to manufacturers and all that. People, we think that all of people say that if you're within plus or minus 10%, you're fine, right? If you want to do 10 gallons, if you're above 9 and below 11, you are fine. You're in the red, in that range. Is there a kind of a margin in terms of improvement? Yes, there is. But here we are now. quickly look at the rectangular field on the left, right? I was doing, what I'm seeing is, first of all, everything is green. I got few purples, few blues and all that stuff. But once I get my sprayer at a constant speed and everything is on, I have a nice, decent application rate, which always stays within my margin of error, all right? Now, when you see on the right image, um, anybody wants to type anything in the chat and let Sandra know that um, how much percentage of green or acceptable rate do you see in this slide? 50%, 70%, 80%? So while you're adding all that, what I want to tell you is that there are areas with some sort of some greens, but there are a lot of areas which have yellows and blue and reds, which is I was applying over the rate. And there are a lot of areas which are blue and purple, which says I was applying a lot of areas under the rate. All right, and it has everything based on our learning to do with your rapid speed transition. I slow down to bypass this grass waterway. I slow down to turn this. I make speed changes. I have to approach headlands. And you can see that every time I'm getting out of the headland or getting into the headland or slowing towards, to pass this, and my section control is turning, on and off. Those are the situations where I start to do a lot of over or under application. All right. One of the bigger things, what we have just seen is on this thing is the maintenance of pressure. Now, I want to also point out that in this field, while we were spraying the field on the right, we went anywhere from 6 miles to 18 miles. We have few spots where we were driving at 22 miles as well. Now, I'm pretty sure, most of you guys are trying to manage our speeds, but we have operators, we have high school kids, we have other people who want to do application, and this can happen. All right. Now, when I go at that pressure, when I go at that speed range from 6 to 20 miles, what do you guys think? What would be my pressure range? Anybody wants to type in? And I can tell you, I really want to maintain 45 PSI here all the time. All right. So I want to maintain 45 all the time. And there was a range which was really good. But in this case, I was going anywhere from 20 PSI to 85 PSI based on some of the regions where my speeds were too high. Now you can select a nozzle which gives you a wide range of similar droplet spectra. But if you drive this fast on a field like this, there will be chances that, you will be outside those pressures, which will give you the droplet spectra, which won't give you the droplet spectra you're expecting. All right. Now, the another thing which happens with most of the flow-based systems, and that was true for one of the flow-based systems we tested a couple of years ago, brand new sprayer, is that when a lot of booms sections goes off and I made rapid speed changes, all right? First, so remember that a lot of boom sections going off means I rapidly slash the amount of flow rate I want to put in the plumbing system or the combination of it. Then whatever the pressure you want in that boom, you're never there. Say, for example, you want 60 there or 40 there or 30 there. It takes a while to depressurize and it takes a while to repressurize your plumbing system. And those are the situations where we see those under and over applications going on. All right. Now, this is a summary of some of the case studies you looked at that I was applying the rate within my plus or minus 10% for only 34% of the time. I don't think that's acceptable, in terms of if I invest a lot of money in there. Now, granted, this is one system. There are other systems which are capable of doing better than that. But again, still there's a significant amount of time where I was doing over and under application. And even today, we will be talking something about the PWM and how the systems have really improved. This trend will still be the same. That means your good application will go up, but you will still do higher percentage of lower application versus the higher application. So we all know under application has direct role to play in terms of controlling weeds. That's one way of managing the population of pests and everything. And if I don't do it, I am giving them an opportunity to be resistant or not be controlled from the critical limits to not get any yield penalty from that standpoint. Now I want to also show what happened on that field, right? The right field with a lot of irregular shape. So you can see that I have a lot of percentages anywhere from 5 to 10 PSI to all the way more than 65 PSI. All right. So when I'm doing all that, you can select any nozzle, right? When you're selecting a nozzle can give you a really good droplet spectra within 15 to 20 psi. Maybe sometime there's a 30 psi range. But the moment you go out of that range, then you are going to either go into the, if you want medium droplet, you will either fall into the very fines, which is your higher pressure, or you will fall into the coarse, if you are very low pressure, right? So these are some inherent things which are related with your flow-based system aspect of it. Now, all of these concerns, whether it is off target, which is my overlap or no spray boundary thing, which is happening, or my off rate aspect of it, which means that this is fundamentally which is not obviously possible in our flow-based systems, is that when I turn, right? And we will talk about how much turning people do typically in fields. When you turn, your outside boom is much faster, your inside boom is much slower. You are going to do a very low and very high application from outside to inside. All right, and that's going to impact how you'll be managing and implementing our application. So this is definitely not possible. We've seen some controller response where it takes some time for the rate controller and everything to bump up the volume in my plumbing system and bump down the volume in the plumbing system as well. Think about it. When you suddenly accelerate, or when you're doing some section control, suddenly half of your booms go off. How quickly they go off? They go off within a couple of seconds. We're talking about 1 to 2 or 3 seconds. All right. Now I'm asking my plumbing system to reduce the flow rate from 30, 40 gallons per minute to 20, 25 gallons per minute. It's going to take some time, right? So these are another thing which are definitely related to that. And we've also seen that the way we apply product at that speed ranges, I'm going to have some droplet spectra concerns as well. So we've talked a lot about it, but on the flip side, I can do better, and the way I can do better is selecting a nozzle which gives me a wider pressure range to maintain my droplet spectra. That's number one. Knowing what my speeds are to be in that pressure range, not try to go too fast or too slow, so that I don't enter into situations of going out of my droplet spectra. That's the number two thing. And then obviously in terms of the controller response, my recommendation, that's my personal thing, is I would rapidly accelerate and get to my speed. I won't do slow acceleration, because every time you are doing smaller step changes in speed, you are trying to get your control system to work on to slowly get there. Now, if I get in, say for example, if I'm getting in the headline, I'm going to quickly go in. So whatever the initial slower bumping up the flow rate is, bump it up, and then I'm going to sit with that. And obviously for the drift control, we talk about staying in my droplet spectra, number one, but definitely boom height. That's my constant concern from that standpoint. Questions? We'll take maybe a 30-second pause here. Anybody has any questions on flow-based? I'll be more than happy to answer any of your questions. And I can call you guys. We don't have many people. Craig, Robert, Dean, anything you guys think is on your mind? No? Are you guys still with me?
Yep, I'm still here, AJ.
All right, cool. All right, so the next thing which I'm really excited about is a PWM, or pulse width modulation technology. You guys have definitely gone through some trade show or seen this technology on one of the field events or dealership or something like that. But the major thing is that now what I've done is that I have taken a little solenoid and put one solenoid in each nozzle body. And so the way this system works is, this system pulse for certain number of times in a second, right? Most of our systems are 10 hertz system. There are a Deere system, which is a 30 hertz system. So when I say 10 hertz system, this system pulse 10 times a second. And within each of that 10 pulses, the longer it stays on, the more flow rate it can put out. All right. So for example, if it stays on for all the time in that 100 millisecond, you are putting maximum amount of product. If it stays on for 50%, you're putting the 50% amount of product. Now, very important thing, guys, here. Think about it, that now I've taken the entire flow control strategy. Means I have flow meter, which is telling my computer how many boom sections or nozzles are on. It tells my flow control valve to bump up the volume. It again checks with the flow meter and keeps adjusting, right? All of those things happen. And then everything has to translate from upstream to the nozzle. Now I have a solenoid which is sitting right at the nozzle, and I can change my duty cycle within a couple of milliseconds, and I can start to put the right rate based on the speed of the nozzle at each nozzle. So once again, I've taken control of flow management from all those components which we talked about, and put this solenoid to make sure that it manages flow on a nozzle by nozzle basis. All right, that's number one. Now, number two thing is, the way this system works is that I input pressure, that this is what the pressure I want to maintain, 50 psi. All right. Now you can speed up, you can speed down, you can have half your boom on or half of your boom off. The goal of this system is to continue maintaining that 50 psi all the time. Now, what I've gained from that, one, if I can maintain my pressure all the time to that accuracy, that means I can speed up and slow down to some extent based on what the duty cycle can go, which, if you ask me, the typical speed range you get is 10 miles. All right. So you get a 10-mile speed range, and all through that speed range, you will always be spraying at the right pressure, and you will be getting a right droplet spectrum. Now, is that right or wrong? Let's see some of the information what we have gathered over the time. Now, this is what the quick simulation or the illustration is. So you'll see these jars. So the first is 100% duty cycle. So if everybody is spraying for the same amount of time, a 25% duty cycle is going to put 1/4 of the volume, 50% is going to put half, and 100% is going to do full, right? So I can just change the duty cycle and start to control what my duty cycle is, and that will change my application rate from that standpoint. But think about it. This is all based on speed, and this will give me is that irrespective of what my speed is, I can maintain my 10 gallon per acre all the time, right? That's the expectation from this system. Now, if you guys remember, we talk about how the pressure changes if I switch off half of the boom or portion of the boom and all that stuff, right? One of the important things which we learned based on some of our lab tests initially, and we will see some of the field data, is that irrespective of how many nozzles are on, you always manage the pressure very tight, within plus or minus 5 psi. That's very, very high confidence in terms of going forward. If I can do that, I'm already doing a lot better. I have a lot of flexibility in terms of what I can do. So what I'm going to show you is some of our data from the field over the last 2 years. So what you're seeing on this screen on the right and the left is that there's one field on the left which has a lot of curves, right? And there are a lot of turns here. There are a lot, there are a couple of straight passes, but I have tight corners on the northwest side of it. I have some tight corners on the south, south central, southeast part of it, and all that stuff, right? The field on the right, it still has a lot of boundaries, which is irregular, but I still have a lot of straight passes which are available. What you're seeing is speed ranges. And what I'm showing you is the target speed I wanted to maintain. Now, very important. This doesn't mean that you have to stay in that speed range. You cannot go beyond 25 kilometers per hour, or what we are saying 18 miles per hour or 16 miles per hour, because beyond that speed, you will max out on your duty cycle. And if you go beyond that speed, you're going to continue applying below your target rate. That's one thing. And I've added a speed, which is a lower speed range as well. That's based on our experience that if you really want good coverage, assuming your booms are nice and parallel and everything, you should stay above 50% duty cycle. All right. You should not go less than 50%. That doesn't mean you cannot apply. You can go up to 30% as well, but your coverage will start to be impacted much more than what you will be having, from 50 to 100%. All right. So this is my good speed. If you can do that. Now again, what you're seeing is typically, like I said, you easily get somewhere in the range of 9 or 10 mile speed range. Now the first thing I want you guys to see is I applied all that product, and you see, I was at speeds anywhere from 6, whatever the speed range was. So 13 miles is like maybe somewhere in the range of 6 miles, 7 miles, or probably 8 miles, and all the way to 16, 17 miles. So irrespective of what the speed was, your pressure was always within the target, right? Now, let me explain how these colors are. Your light green color is the pressure range where your flow rate error coming out of your nozzle is within 5%. That is much more than what we talked earlier, plus or minus 10%. No, we're not talking about plus or minus 10%. You're talking about plus or minus 5%. So all of these green regions, if you did what you did in this field, your rate only from the pressure, there are a few other caveats we are not going to talk today, but if we talk about pressure, your pressure represented your rate to be within plus or minus 5%. All right, that's pretty big deal. On an average for both of these fields, somewhere in close to 87, 90%. What happens in these fields, right? You have some scenarios where you are applying at pressure. So the two other ranges which I'm showing here, which is, if you see this, my yellow range, that is a flow error of within 5 to 10%. And then the reds are beyond 10%. All right. Like the dark green is plus 5 to 10%. And then blue is plus 10% and beyond. So there were a lot of regions here where you applied, over and under, but you were still, most of these areas, whatever the 10 or 12% area was left, you have, and you can see in these percentages as well that you have maybe slightly a little bit under application higher than than over application, but very few areas which showed beyond 10% of error, right? So which is such a big deal moving forward. Similar things happen here, and if you match what my speed was doing every time I was slowing down or speeding up to go over the terraces and all that, that's where these errors were happening, because I was rapidly slowing down and rapidly speeding up. Similar things which we have seen in the flow base, but at a much lower magnitude, from that perspective. Now I want to ask this question, and this is a question for Sandra and Keith as well. Have you ever heard about what is pressure coefficient of variation? We have heard about coefficient of variation in terms of my seeding. What is my singulation? When we are planting thing, we always talk about coefficient of variation. And if you guys, I mean, I'm pretty sure you guys plan and all that. From a planter perspective, I want my COV or coefficient of variation to be definitely less than 33% for good seed spacing, or from good systems, I expect them to be somewhere around 20%. All right. So have you guys heard about what the pressure COV is? Keith, Sandra? All right, no. All right. So I want you guys to um, to 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 start thinking about this now, because when we say C coefficient of variation of pressure, I want to also talk about, I've seen, so in my previous slide, right, we've seen that what my pressure ranges were. Now, from a COV standpoint, I want that each of my booms, or all the nozzles within each boom, where do the pressure stands? Because my goal is to maintain whatever 50 psi here in this field was, but I want that 50 psi should be all along the boom, consistent at all the time. All right. Now, what you're seeing is these COE values, and my CVs in all of these fields, I was, PWM pressure CVs were less than 10% for 96% of the time. Now you have to ask me this question, what does that mean? Because when we talk about CV of my seed spacing, as I keep going lower, so 33% is I have to have it, otherwise it's never going to look picket fence, right? But at 20% COV, my plant spacing starts to look really good, right? Really good means, I'm within half an inch or an inch of, all the time. Now, when I say that it was less than 10% for the 96% of the time, that means that pressure across the boom in all of the booms was within plus or minus 5 psi all the time. That's a very tight, pressure management, not in one boom, but all the boom, irrespective of my turning, my straight passes, speeding up, slowing down, everything included. All right. So I want you guys to start talking about what is your pressure CV. Do you know what pressure CV is? Because when I say pressure CV, I want to make sure that I am managing my pressures accurately all across the boom and from a nozzle to nozzle perspective. So now what I'm going to show you is another slide here, which is, remember we were talking about droplet spectra. I purposefully skipped the last slide for a certain reason, but if I select the right nozzle, now I selected a right nozzle in this case, which gave me 20 psi range to always stay in my target pressure. And you have to select a nozzle which has a 20 psi range from your target rate. Say, for example, 50 was my target. So somewhere between 40 to 60 psi, I should always get the same droplet spectra, or even if it is something wider than that, even better. So if I selected a right nozzle with everything what I did, I wanted to maintain medium, I always maintain my medium droplet size. So think about this thing, switching to my PWM, I have a 10-mile speed range. I can manage my pressure for good 90% of the time. My pressures were consistent from nozzle to nozzle, from end to end on the boom, within 5 psi all the time. So if everybody is going up and down a little bit, everybody was right there. There's nothing like one was too high or too low, and pressures are too high and too low as well, right? So that's very important from each boom perspective. Now, questions up to this point. Sandra, we still have people with us?
Yep, we still have Yeah, do I have somebody that wanted to ask a question?
Yeah, it's Keith. So
Okay.
really, that that variance, it is repeatable for each nozzle going across there. I mean, that's what
Absolutely.
you're getting at is, what 96%. That's very, very similar and repeatable all the way across, right?
Yes, sir. And the way we did this is that we put two pressure sensors in each boom, and we put those pressure sensors strategically, one right at the T where the product gets into the boom, and one pressure sensor towards the far end, just to capture where the product gets into the boom and all the way to the very far end in terms of seeing whether the pressure was building right or wrong, right? So we calculated these CVs on a boom section by boom section basis and combined all that together. So everything looking together, this is what you have seen. And this is, so this, the field on the right is 140 or 160 acres. The field on the left is 70 acres. This data is at 40 hertz, means I'm collecting 40 samples of data every second. And one more thing I want to emphasize is that this is a very high resolution map. This is a map which has been plotted for all 36 control sections in that spread. So you are seeing every single section's behavior in this map. I'm going to show you another slide here. Let's move on with the, so this is one example, right? So every single dot is one control section, and you can count from the left to the right, there'll be 36 dots. So you are seeing simultaneous behavior of all of those sections, what they would do. That was pretty powerful in terms of how it is happening here. You can see sometimes the backward movement of the boom. You can see on these turns that it turned on here, but there was some gap in the distance when it turned back on because the boom moved too fast. And my duty cycle, the way it was definitely not matching up and all that stuff. So, and we won't go in that detail. What I want to quickly say and emphasize to you guys is that what I have plotted here, and I only want to show this slide to you guys because I want to talk about something else. We are shortchanging on time here. Is that on a flow-based system, we cannot manage that kind of a speed, because if we will manage that kind of a speed, we will be from a very high end of a pressure to a very low end on a pressure, right? We will be in areas which are below 10% and after the 10% as well. So so this is what is happening in this case. You can do it, but then you have to really manage your speeds well. You cannot drive that fast, or you cannot drive with that speed range. And if this is the case, in terms of pressure, you won't be able to manage your droplet spectra as well, because you're going to go from fine to medium to coarse based on the nozzle we selected in this case. All right. Now I want to talk about is that I'm sorry I showed this. So Sandra, can you ask the fourth question to everyone? I hope I didn't busted my. It's time to ask the question number 4.
Okay, so I'm just going to have them put that in the chat. Whoops, I used the wrong one. Stop share. Okay. Share. And we want, oh, I wonder if I took that down. Alrighty, let me find my PowerPoint here. I don't know what happened to that, but that went down. So let me find that one. Okay, I'm going to have you, rather than do this one, I'm just going to ask you the question. So, alrighty. The question is, what percentage of area in your field falls in a turn or a collinear passes, or when he was talking about when you turn. So what percentage of the area in your field falls in a turn area? Remember that he showed where that sprayer was skipped it, or a curvilinear. I don't know if that's how you pronounce that, AJ. What percentage of area in your fields falls in turn or your curvilinear passes? Is that the correct how you pronounce that? He's not getting on, but what percentage of your fields do you think you're in the turn? I think that's probably the easiest one. So just throw out some percentages there. I'm just going to put some guesses here too.
So how about Sandra, I would like Keith and you to throw out a guess as well. And what do you guys think? 25%, okay. 5%, 45, okay. So my next question, if that is the case, is if 45% of the time I'm doing turns, think about it that my flow-based system cannot do anything on turns. There is no way I can do it. I can do it. I have to have 5 different control systems for each boom. So, and still I won't be able to manage on a nozzle by nozzle basis because all I can do is up to a boom level. But I still have to have 5 flow meters and 5 rate controllers and all that stuff. All right, so let's see very quickly. Let's go. I think this is where I am, right? Yes. All right, am I back? Sandra,
yes, you're back. Yep, okay. You're back.
So one thing I quickly want to share with you guys is this is the thing which we did last year, right? You know, we picked it up and you have seen some of a field like this, you know, there's another field like this, and there is another field. So all of these fields are spread out in Clay Center, maybe one in Wamego, but they're all farmers field, right? Typical boundaries and all that. You know, we have a house here, there's a grass waterway, a smaller patch here and all that stuff. So my guess, you know, you guys are pretty, you know, bold in terms of telling how much turn compensation. My guess was that we should be in the range of 8 to 10%. But 8 to 10, it was not 8 to 10%. It was, we are in the range of 20-ish% in terms of turns, right? Now, there are turns. So what we have done here is extreme turns. So extreme turns are turns which are 20-degree turns, right? Which means I have a lot of speed differentials from end to end, right? That means if that is the case, there will be a huge rate differential from end to end as well. Now, medium turns are somewhere between 20 to 50 meters. That also has somewhere around 6 to 7 mile speed differential. My slide turns have 3 to 4 mile speed differential, and my straight passes absolutely not. So think about, where do you see? So Sandra, this is a question, and Keith, to you as well. Where do we see more and more or newer instances of, you know, resistance or weeds which kind of are left without control?
Okay, AJ, could you ask that question again too?
So year after year, which areas do you see have resistant weeds showing up, or newer areas where you did not see the resistant weeds before, they are showing up in those areas? So the question is, where do you see those resistant weeds, or yeah. So most of the time, if you ask me, you know, from that standpoint, most of those things are going to be edge of the field. Exactly, absolutely right, Craig. And things where headlands and, you know, in and around all of those places where either you do rapid speed changes, that's my chance of, with what we saw earlier, that it's gonna end up doing over and under application. Or in the areas where I do a lot of turning, that means I'm putting a lot more somewhere inside, but I'm putting a lot less on the outside, because those are the areas I'm going to be moving my boom much faster. So we have to be very cognizant about what this technology is giving me in terms of turn compensation as well. So what we have, kind of seen in terms of what it is going, that we haven't done much work on that, but my guess is that these systems are managing duty cycles correctly as they are going around. But if that is the case, then I am managing my duty cycles all around these curves and making sure that I keep my application rate consistent, not only in the straight passes, but also in the curvilinear passes as well. All right. Now, this is what you will see in terms of speed differential. Extreme turns anywhere between, and the inside could be 2 or 3 miles, and outside could be 45 kilometers, right? That's a huge speed differential. Even at your at your 50-meter turn, which is 20 to 50 meter, you still have anywhere between 34 to, this is 15. So that's a pretty large speed differential as well. So big picture, we cannot do that. All right. Now we have, I quickly want to wrap up this thing. From a comparison standpoint, you can do good with flow based, but you have to make sure your speed is in a good range, your pressure doesn't vary too much, and your droplet spectra stay like that, right? And but there is a limited control, because everything is controlled by what your speed is. On a PWM, you get some wider speed range, you keep your pressure constant. We have seen that. We can manage our droplet size. We can see that. And we have also seen you have an advantage on turns. We have seen that from that standpoint as well. This is just a simple, very quick thing. We haven't done much. We are on the cusp of doing something in 2 weeks, which will be all in the field. But some of our lab studies have shown that if you stay above 50% of the duty cycle, that your coverage is going to be much better. But I'm eager to do the field study, which we are planning in 3 weeks, and we will know a lot more about the difference in coverages at different duty cycles, plus, which is a 10 hertz systems, which is everybody else, and 30 hertz system what Deere has. So we'll try to share some of those things. The last thing I want to talk about, boom height. Very important, guys. We have to make sure our boom heights are always consistent. If they go up, we are gonna be out of, in terms of, overlaps and coverage. And like I said, always remember, my boom goes up and down on a pivot point. So if it goes up like that, and I'm spraying now at an angle versus down, right? So suddenly you start to lose a lot more product. It's not going to end up. And there are a lot of good presentations from Dr. Greg Kruger at UNL that, which talks about wind speed as well. So an additional 5-mile wind speed can blow your, droplets to a very long distance. We're not going to talk about that. But last slide, for everybody, is what you see here is I mounted 3 different wind speed sensors, all right? And I mapped them side by side. So this is my one pass going up, which are these colored things, and this is a pass coming down, all right? Now so this was my wind speed when I started in the morning, which is northeast. But within a span of 4 hours, it completely flipped and started blowing southwest. And now what is happening is that when I was going southwest, one is the speed of my sprayer chassis, and the additional wind component which was blowing from my back, my effective wind speed was 23 miles per hour. And when I was going up, I was in the mix of 5-7-ish mile as well. So one pass, I do a really good job on application and expect to have good coverage. On the other pass, I have no idea where my droplets are going. 5% landing on my crop or 10%, but it's all over the place. All right. So this is something which we have to live with because the way our fields are set up, but have to be conscious about wind. Wind is one of the biggest factor for drift. If you add any kind of not good, boom height control, it could be really detrimental from that standpoint. So I would really want to acknowledge some of the people who have been helping a lot on the back end. CNH, Raven, and TJet. Most of their help is in terms of technical expertise, so that we can tinker around in their systems and get some really good quality data for you guys. So it is my information, my email, my Twitter handle, and all that. Feel free to send us questions or send us something which you want us to do this year. We have access to sprayers, brand new sprayers every year. So we have two brand new sprayers this year. They're all PWM system fitted. We have full flexibility without any strings attached to do whatever study we want to do. So do not hesitate to send questions or queries that, hey, AJ, have you seen that? Or can you do something? Can you bring some data like that next year? We'll be very happy to do that. So yes, questions now or later, or whichever way you guys want to start.
Okay. Okay, I will stop you sharing here. I do have a quick question, AJ.
Yes.
A lot more people or producers are spraying their own fields, getting their own equipment. And I know that you talked about that nozzle types are very important.
Right.
So there isn't a one size fits all. Is that correct? So each chemical, they have to get a different nozzle.
Right. So there are two factors to it. If we talk about, I am not a nozzle guy. First of all, I really want to throw that out. The turbo TJet nozzles are probably more popular. People use Hypro, and Hypro makes nozzle for John Deere and everybody else and all that stuff. But those flat fan nozzles are really popular. Those where for a lot of application aspect of it. And then there is a component of twin fan, which is spraying into the crop backward and then forward moving. So it tries to cover the canopy on both ends. But yes, Sandra, your question is absolutely right, because my nozzles all have to be picked up based on my chemical chemistry. So if I want that this cocktail needs a medium droplet, right, then I can use that nozzle for any other cocktail which needs medium droplet as well. But the only other caveat will be that, do I want to move away from flat fan to something else? My guess is most of the time we use either flat fan or twin. We have people use air induction for flow-based system. Then there are other patterns. I do not think that we use a whole lot of hollow cone or solid cone nozzles in our application. They are more popular in tree fruit industry. But there will be two things: the shape of your spray pattern, which is your droplet cloud, and the droplet size. If that is similar, you can use that nozzle for other cocktails as well.
Okay. Would it say on your label which nozzles that they're recommending? So there you go. You got to go back to the label.
Exactly. So your label will say that you should be spraying at this droplet size. It will also tell you what rate you want. So my droplet size is my selection mode now. Say, for example, this application needs flat fan. I'm going to go in the flat fan booklet, and I'm going to look at, so it also has a pressure component in the label as well. I'm going to look at the pressure and my droplet spectra. I'm going to start matching which nozzles are available. It could be that I already have that nozzle I can use from that booklet or from my bank of nozzle, or I'll go in my booklet and pick up a nozzle which gives me the droplet size range and my pressure around that application pressure and the for that speeds and all that.
Okay. Is there any other questions? I do have one more, but I don't want to ask questions if somebody else has one. Okay. You talked about the two different systems, AJ, the flow-based system or this PWM, which is a new technology. And maybe you don't have this right off the top of your head, but how much cost-wise would it be to convert a flow-based system to this PWM, or would you have to start over completely?
No, you can convert almost every sprayer from flow-based system to a PWM system.
Okay.
And my guess, this is a difficult thing to answer based on the cost, and cost has to do for the nozzles as well. But my best guess is that, you know, to convert a 100-foot sprayer, you might end up somewhere in the range of $35,000 to $40,000 to convert from a flow-based system to a PWM, because one of the biggest costs is the change of the nozzle bodies, because those older bodies will not work because they don't have the functionality to add the solenoid, because these bodies have to have a solenoid on it. So the new bodies, then you have to add a solenoid. Every nozzle body will have a solenoid, so that's costly. And then there are some cabling and, you know, some little ECUs or controller and what, depending on whether you're buying a T-Jet or a Capstan or a Raven, you know, from that standpoint, yeah. But like I said, every sprayer can be retrofitted from flow-based to PWM.
Because it sounds like the comparison is keeping that pressure constant.
Right.
And is that the biggest difference between these two systems? Is the pressure?
I would definitely say so. The amount of work the flow-based systems have to do when we rapidly do speed changes and a lot of sections are going on, it always goes back and forth in terms of looking at what amount of flow rate I should manage. That becomes too much of a work. And Sandra, think about, if you have seen a sprayer, we have this huge 2-inch, you know, or 2.5-inch hoses, which are putting, you know, taking the flow from the pump, you know, all the way to the back, and then I have a 1.5-inch hose or 2-inch hose, and then it spreads out to a 1-inch hose. So, and the flow meter is sitting somewhere in the, you know, they're no longer sitting upstream. They are very, very close to the boom. But when you have to manage smaller flow rates in these larger pipes, it's not an easy task for them. You know, those systems, they like to stay full all the time so that I can make minor changes. So so pressure definitely, but see, it gives you, so if you have to ask me three things: bigger speed range, good pressure, which is also make sure your droplet size, but the ability to manage your rates on straight and turns. That's the another, we should not forget. If you are putting wrong amount of product on 20% of your land, I am screwed. Because that's a lot of area, you know, which can really get me into trouble in terms of managing my weed or pest, and obviously it's going to start impacting my yields.
Okay. Okay, well, if you guys have any more questions, please contact Keith or I, and we can definitely get your questions answered. And I know we kept you on here a little bit longer, so we wanted to give you some information, or we wanted to thank you for participating in this. In the chat box, there is a link directly to our evaluation for this. So we'd appreciate if you take a couple minutes, click on that link, and it will go to your our evaluation form for you. So we really appreciate you doing that as well. There's probably going to be some more planning and crop programming here in the future. I know our wheat test plots are coming up. Our post-rock one is at the end of this month, May 26th. We're going to, so watch and go to our post-rock website. Keith, do you have a date for your Norton County test plot at this time? I don't know if he does, but watch. Yes.
We're working on it.
Okay.
Either the 6th or 7th of June, or maybe that next week. We're trying to just see, work some routes out and see where everybody's at.
Okay, so go to your to the websites. Go to Twin Creeks or go to Post Rock or whatever district you're in. Just go to their websites because it will be on their events on the main page. So Again, thank you, AJ, for presenting that information. This will be recorded. This is recorded, so these will be posted on our Twin Creeks and our Post Rock websites. We'll also give it to AJ, and he may post it on the K-State one, and we'll share that on our YouTube channels. If you want more of his handouts, the PowerPoint, we will post that as well for you. So AJ will get that to Keith and I, and we can post this PowerPoint that he presented as well.
I can do that. Yes. Yes.
Okay, great. If you have any more specific questions for AJ, you can either email him directly or email Keith or I, and we will get those questions to AJ. And like he said, I know AJ is very willing to answer your questions, get some on-farm research out here with your questions that you have on your farms, so we can get your problems and situations, concerns answered out here, because we are here for you. Okay, any other questions?
My last minute pitch to everybody will be, do not hesitate to talk to your tech expert, right? You know, whether it is Deere or CNH, visit with them, ask them about how this system works, because there's a lot to cover in this 1 hour. We cannot cover everything, but talk to them. Try to get a little bit more education around it. And I have sent a link to Sandra, and on that link, there are 4 or 5 smaller extension articles, and they are really good one. I like all of them actually. So you go out to read them, and yeah, try to ask questions. Ask them, how can I do better with my sprayer? And if you don't get an answer, you know, come talk to us. We'll try to get an answer for you.
Okay, all righty. Thanks again for joining us, and we'll talk to you later. Thanks.
Thank you. Bye-bye.
Thank you, everybody. Thanks, AJ.
Thank you, Keith. Thank you. Bye-bye.
Okay, Keith.
Yeah.
I moved them in the waiting room, so I don't know why my pull everywhere wouldn't work. Anyway.
Yeah.
I'm going to stop the recording real quick. Just a minute. There we go.
Okay.